Good morning and welcome to this crash course within machine learning operations, also called MLOps. And MLOps is a rapidly evolving field, and it's crucial for companies that aspire to scale the benefits of machine learning. So I'm very excited that we have almost 200 people online listening from different parts of the Northern Europe. And I hope that you had a good chance to get some coffee before we are now kicking off the crash course. And the goal of this crash course is to help you understand why MLOps is crucial to scale the benefits of machine learning, to understand what MLOps is, and how you can implement it in your organization. And my name is Niklas Lidholm, and I come from the consultancy firm Solida, and we are the data company. And our mission is to create value from data in a connected world. And we strongly believe and see that a lot of companies still have huge data opportunities that remains unexploited. And that is why we are offering a combination of management consulting and implementation consulting services to really help our clients turn these opportunities into realized business impact. And we partner with all of the leading data and integration technologies. And that is why we're also very happy to have Jelena Usonovic with us today from AWS. And Jelena, she works as a principal solution architect at AWS. And you have a quite impressive background, obviously helping clients with MLOps at AWS, but you also have a lot of experience working as a consultant in previous consulting firms, focusing on machine learning projects and also data science related projects. So warm welcome to you, Jelena.
Yeah, thanks. And I have co-created this course with Niklas Lidholm, who is a management consultant and managing data scientist at Solida. So you can already hear that Niklas does both business and technology part of consulting. And he has been doing that for almost a decade now, helping clients spot and realize data opportunities across different industries, across different domains. So Niklas is not exclusively focused on MLOps technology, but MLOps has always been a big part of how he and his teams succeed in delivering these data projects. So he will tell us more about that during this crash course.
Thank you, Jelena. So the agenda for this presentation is, as I mentioned, go through why we need MLOps and what MLOps is and how we can implement MLOps in our organization. And we will go a bit on the higher level and a bit on the lower level. So I think there will be something for everyone in this presentation. And also, please raise your questions in the chat. We have saved some time in the end to do a Q&A, so we really look forward to address your questions at the end of the presentation. And we will end the presentation sharply at 10 o'clock. So, warm welcome. And before we move into MLOps, let's just do a brief introduction to machine learning. And machine learning are certain algorithms that enables us to, or models to learn from data. So let's say that we have collected data on customers that have either churned, being this image the red dots, and have not churned, being the green dots. And let's say that we have also collected some additional data on how much a customer is using the service and how satisfied they are with the service. We can then train a machine learning model that enables us to separate and predict which customers are more likely to churn. And this is a quite simple supervised machine learning model. And the whole point of doing this is then to use it on new customers and make predictions or what is called inferences that we then can act on. Like if we know that there are certain customers that have a higher risk of churning, we could then target these customers with a specific retention offer, as an example. And well, this is a very simple example, but machine learning is becoming much more sophisticated, and it's also rapidly becoming more naturally integrated in many of the products and services that we typically use today. So we now get movie recommendations when we look at Netflix, and we're able to communicate directly with our phone through speech. So machine learning has really become something that the average person is often exposed to through different products and services. What might not be as evident, though, is the quite vast opportunity there is for companies to apply machine learning broadly in the organization to drive sales, resource efficiency, and also grow customer value. And we typically see this. These are just examples, but just to provide some examples, it is often used, for instance, in digital services to work on dynamic pricing, or it's often applied in CRM to build next best action recommendations, to drive upsell, cross-sell, customer satisfaction, etc. in the customer journey. It is often used in marketing to drive intelligent targeting. In operations, it's often used to work on demand forecasting, etc. So there are quite a broad set of opportunities in terms of how we can apply machine learning broadly in the organization. So companies typically have quite extensive opportunities that they can compile and then prioritize based on the expected business value for this initiative, but also the complexity in terms of realizing this specific use case. And you can use this as a way of prioritizing your use cases. And then when you're clear on prioritization, you can then start to convert each of these use cases into a continuous stream of business impact and customer value. Now, according to quite recent research from McKinsey, it turns out that only 28% of organizations have successfully adopted and scaled machine learning in practice. And this, of course, has several explanations, but one important part is that it is quite hard to scale machine learning. So then the obvious question becomes, why is this the case? And while it has become a lot cheaper and easier to build machine learning models and sort of do proof of concepts, I mean that we now have quite easy to use tools to apply different algorithms, and we have also seen an explosion of data for which we can actually apply these algorithms to, and we also have much better compute and storage resources to actually benefit and leverage this data. But scaling still remains something that is quite hard to do if you don't manage your efficiency. So if you are on your beginning of your journey, you might have compiled a business case to start work with machine learning. And you sort of get the management to buy in on these projects. And if you're then effective, and this is of course a big milestone itself, you get your first use case in production. And if this use case can prove its value, you might start to get a higher understanding of the organization for how you can apply machine learning, and the business might start to pull for more use cases to be implemented. And this is sort of one of the first milestones to pass in your journey. And then you start to implement more use cases. And while you're of course getting traction, which is very important, you also start to see a higher need to maintain and manage all these models that you're now putting into production. So you start to see that there's less time free to work on new use cases. So now when you move into this scalability phase where you really want to scale out and create more business value across the organization, you might instead risk falling into this sort of maintenance trap where you don't really have any specific time to either work on new use cases or improve the ones that you have actually deployed already. So what might risk happening is that you then instead start to see some of these models start to decay in performance, and this might be something that is then affecting your stakeholders. So they are, in a sense, then losing trust in your models. So sort of rather than following this successful path where you're really managing to scale the value of machine learning, you instead fall into this maintenance trap where the business value starts to fall down instead. And if it gets really bad, the organization might start to question the value of the analytics function, and you might also have key team members quit the team, which sort of additionally would add to this problem. So why do you need MLOps? And MLOps is critical to scale because it frees up time for new use cases. It speeds up the time for how we are delivering and creating value for these use cases. And it also ensures that models remain valuable and reliable over time at a lower risk. And ensuring reliability is quite hard because the world is not static, as you know. So a model might be performing well in the beginning, as you can see in this sort of conceptual image, but then something might happen to its performance. And this could be something that happens suddenly or gradually. And if this is not really acted upon, then we might be using a model that is, rather than creating value, is actually destroying value. So being able to monitor this is very essential. And models, they typically degrade in performance due to something called either data drift or concept drift. And data drift is what happens when the input distribution changes. So let's say that we have trained a churn model, like the example that we provided in the beginning. And it performs quite well in general, but it turns out that it's not performing that well on price-sensitive customers. But this is not generally a problem because we don't have that many price-sensitive customers in our customer base. So still the model on an aggregate level is quite effective. But what happens then if we become more aggressive in acquiring new customers, for instance, through high discounts? That could lead that we then start to attract more price-sensitive customers, which the model then is not performing well on. So now when we start to see more price-sensitive customers becoming a lot more common, then that would trigger a decay in model performance. So there's now a lot of misclassifications in terms of churn that we previously didn't have. And when this happens, this is referred to as data drift. The other problem is concept drift, and that occurs when the relationship between the model input and the model output changes. So let's say we have the same scenario, but now let's assume that instead a competitor launches an attractive product that is targeting to a specific customer segment. Then some customer segments, for instance, let's say that this is very attractive for families, might find this value proposition a lot more appealing compared to our product. And then we might see a different behavior for these customers who might then have a preference for this new product and churn as a consequence. And this is sort of an example of concept drift, which is often triggered by something externally happening in our environment, which sort of changes then the relationship between the input variables and the output variables that we are modeling. So monitoring a machine learning system is essential to ensure that models remain valuable and reliable over time. So in addition to monitor, of course, the model performance and data drift, etc., we also need to ensure that we monitor biases to ensure that our models are ethical, and etc. And we also technically need to monitor our inference endpoints, etc., to ensure that things are technically operating correctly. So we really need MLOps to sort of manage and streamline the complete end-to-end model lifecycle. So that is when we are sourcing data and we are training a model and we are using that to then test and validate that model on our data before we are then deploying the model to be used in production. And then we need to continuously monitor the performance of the model and then retrain if the model performance starts to decay. And we need MLOps to streamline this cycle. So what is MLOps? Sort of understanding MLOps conceptually, I think it makes sense to think about two different analogies. So scaling requires two different modes of operating. First, we need to establish the lab where we sort of facilitate rapid experimentation to find solutions to our most valuable problems. But we also need to establish the factory to ensure efficient, reliable, and repeatable and scalable delivery of value for the solutions that we have built. So we need the lab and we need the factory. And MLOps, that is essentially what MLOps tries to support. So MLOps is a set of practices to manage our machine learning models in production in a reliable and scalable way. And we can sort of see this as we are working on 3 different continuous processes. So first we need to speed up experimentation, and this is essentially the lab part, where I think reusability is, for instance, a key element here to be able to reuse structures that we might have created in other cases. And then when we have sort of experimented and found a working approach for how something could be solved and modeled, then we need to convert that into the factory and automate the training, testing, and the deployment of the models to ensure that we can work in this second loop where we are sort of continuously refining our models over time. And then we finally need to ensure that the third loop is working properly, which is where we are really running our model in production and monitoring the performance to ensure that the model remains reliable and valuable over time. So when you talk about DevOps, you often are more focused on code, but MLOps also helps us manage the complexities and dependencies that does not only relate to code, but also data and the models themselves. So why is then machine learning becoming more attractive to invest in? And implementing a machine learning system is complex, and Google published this quite famous paper during 2015, which was called Hidden Technical Depth in Machine Learning Systems. And I think it was quite clear on the fact that the machine learning code, or what you say, actually only composed of a small fraction in terms of what the effort of sort of building this type of system. So in addition to building the machine learning models, etc., you need to manage your data collection, you need to extract features for machine learning consumption, and you need to ensure that data is always verified, etc. And then in addition to that, you need to build your serving infrastructure, and you need to build your monitoring capabilities around your solution, etc. So there are quite a lot of stuff that you need to implement in addition to the machine learning code. The good news here is that there's been an explosion of different open source and commercial tools coming into this space. So since this paper was published in 2015, we have seen now a lot of different tools coming in. Like all the different cloud vendors offer their tools in this space, like Azure Machine Learning or AWS SageMaker. And we also have open source tools that are typically used like MLflow, and there's also a lot of commercial vendors that are now operating in this space. So I think cloud and MLOps specific tools has really reduced the complexity and the total cost of ownership in terms of building and operating these machine learning systems. So in a sense, this trend is pushing what is feasible. Solutions that were previously very complex to operationalize. I'm not saying that it's not complex anymore, but it's at least a lot easier. For instance, when you need to scale to millions of consumers in real time, or whether you need to operate machine learning on the edge, that has become a lot easier to do in practice. And it's also easier to apply state-of-the-art algorithms on large amount of data, and sort of we can benefit now where, for instance, when it comes to open source, where we see a lot of the algorithms that are implemented in research being now implemented as in open source tools, etc. And it also drives lower TCOs, or total cost of ownership. So for instance, we have radically improved solutions for model management. I think for me as a practitioner in this space, since the last decade, I think this is a quite big change and positive change for how you build these type of solutions. And you also get access to cheap, scalable compute when you need it. So you don't need to buy a lot of hardware that you need to have up and running all the time. You can just use hardware whenever you need it, which is, I think, very important when it comes to these type of solutions. And there's also a lot of different open source and commercial tools that are more or less suitable for different needs and preferences, like whether you prefer a code first or no code approach, etc. There are a lot of different tools that are specialized on different needs. If we think about the business case, a lot of the use cases like 5 to 10 years ago were probably didn't make that much sense to implement. They might be too complex to implement, or the business value would be, because the cost of implementing these use cases would be maybe not that high. But now when we see a reduction of complexity and also that we can implement these use cases in a much more efficient way, we start to see now that the overall business case for many companies are starting to improve. So how then can you implement MLOps in your organization? And before moving into some technical examples, I just want to emphasize that MLOps is not a pure technical problem. So in addition to obviously the technology, you need to manage how you set up the organization and the ways of working, and you also need to think about the type of skill sets that you need to operate effectively in this space. And then I think it's very important to architect solutions for reuse. So for instance, you typically build a data platform, and in this space you then establish a machine learning platform with its certain capabilities, and then you should aim to sort of build your solutions on top of these platforms with a high degree of reusability. And I think this is sometimes a big, broad question, but when it comes to the roles you typically need, in a simple way, you can think about it as obviously you need a data engineer to build the data platform, and you need something called machine learning engineer to build the machine learning platform, and then you typically have data scientists working on the specific use case. But in practice, I think this could look a bit different, but in general, there are different competence needs when you do this type of things. So now, establishing MLOps, I think that is best approached as a step-by-step journey. And there are different frameworks that describes MLOps maturity. This one is adapted from Azure Machine Learning or Azure's framework. But I think all of these frameworks provided by AWS or other firms are quite similar in terms of what is included in these steps. But in this framework, we have 5 different steps. We start off with no MLOps, and then we move into sort of applying DevOps practices, and then we automate training, and then we automate model deployment, and then we automate lifecycle management. And the more mature we get, the higher is our ability to scale. So my intention now is to exemplify this maturity framework through a case. And the case was at a tech client, so the main objective there was to establish their data science function and work on different prioritized use cases related to, for instance, predictive customer lifetime value, which is what I will exemplify in terms of MLOps maturity, but also prescriptive churn management, content recommendation systems, business forecasting, etc. So the engagement here was not mainly about MLOps, but MLOps was an essential part when we moved from having 0 models to above 100 models in production within less than a year. And we implemented the ML platform on AWS, but using a lot of cloud-agnostic open source tools. So we implemented this, I will have another image for this soon, but we implemented this architecture with 2 data scientists. I was one of them, leading the work, and 1 visual analytics consultant. And we already had Snowflake as a data platform and Tableau as a visualization platform established when we started off. And we were building Python-based workflows executing as Docker containers to isolate dependencies when we were running the pipelines. And excluding the Snowflake cost, which of course is the heavy lifting when it comes to data, the monthly cost or the cloud-related cost to operate this was actually very, very cheap. It was less than 1,000 SEK a month, even though we were running quite many experiments and inference at scale. And we established this platform gradually based on automation and scalability needs that we have in the short term, but we sort of had a longer term thought on how the target architecture should evolve. And the goal was really to move fast and to use tools that in the end facilitated what was the main objective here, which was to establish the data science function. And I'm not going to go through this in detail, but this is sort of the architecture that we set up. So as I mentioned, we had Snowflake as a data platform, but the main component that I want to focus on now is how we set up the model lifecycle management or the model management platform, which is MLflow. And we also, to manage compute in our training and inference pipelines, we use the AWS Elastic Container Service to be able to run container workloads. So that is something, and so I will mainly focus on this middle part when it comes to the case. And obviously around this solution, we set up a sandbox environment to facilitate experimentation, and we also did a lot of the visualizations like decision dashboards, etc. And we built monitoring capabilities in Tableau. And in addition to this, we also, of course, had to manage security, but that's not something that I will go into there. But there are specific tools that you can use to set up that. So focusing on the case or the project that I want to focus on is how we establish customer lifetime value. And just to get a sense of what that is, one challenge when you're optimizing marketing investments for a subscription-based company, which this is that different customers have different customer lifetime value. So in a sense, you're paying a certain amount of money to acquire a customer, referred to as the customer acquisition cost. And then obviously you want to attract customers that are expected to be worth more than what you're paying for them. So in this case, let's say that we acquire a customer that is only interested in trying out our service for free, then it would be an easy way to burn money to be effective at acquiring these type of customers. So obviously what we want to do is to be effective in acquiring customers that are expected to be worth more than what we are paying for them. And this is quite simple unit economics, but the problem here is really for a subscription firm, how can we know about the profitability beforehand? And that is why we needed predictive LTV. And the main focus in the beginning of this project was to reach proof of value for working with LTV. And when setting up the project, we were thinking about, on a high level, 3 different streams. So we obviously had the value realization part, but then we were building the insight capabilities like LTV models, and we were also doing investments to have us operate more efficiently. So when we started off the project, we set up our sandbox environment to facilitate experimentation, and we could then work and build the first delivery, which was to provide descriptive calculations on customer lifetime value, which we then could supply to the board. So this was the first delivery that we did in the startup sprint. And after that, we could then start because then we were a bit more, then we had done some exploratory data analysis and we were a bit more into the problem. So then we could start to architect a bit more the data architecture to facilitate experimentation. And that then enabled us to build the first predictive LTV model for the first market. So this subscription-based firm were operating in about 10 markets. So we started off with building a model for the biggest market, which we could then deploy in the first use case, which was related to ads bidding optimization. So starting to feed back the value estimate to the digital channel so they could optimize how much we pay for specific ad exposure. And DevOps was, when we set up this part of the project, DevOps was very essential to set up to collaborate. So the shifts that we did was to move from local development, where we had a lot of dependencies in how we were running the code, to having a versioned and collaborative sandbox environment. And I think the biggest and most important investment was related to, or moving from having ad hoc pipelines to thinking and creating this more reusable data architecture that would facilitate experimentation. And we start off with notebooks, and they are, I think very excellent when it comes to working in the lab or doing general modeling. But then in order to when we have sort of found this successful approach, we needed to scale up and roll out these models to more markets. And then is when we started to more think about MLOps in terms of how we could automate the training and deployment pipelines, because there was still now a lot of manual work when building these models, and scaling to about 10 markets would be really time consuming for the approach we took. So we automated training and deployment, and that enabled us then to improve the predictive LTV for the first model, but then also scale out the predictive LTV models to all of the markets, and then ultimately also scale out to some of the prioritized use markets in terms of doing ads bidding optimization or value bidding. So automating training pipelines was essential to really speed up model creation across the different markets. And when you work on machine learning, it's very experimental in nature, and it's very time consuming to sort of trying to manually find the best model based on all the different features that you can apply, the different algorithms and hyperparameters and the different modeling approaches. And as I mentioned, in our case, we had a multi-step pipeline, so it was very time consuming to do this manually. So the shifts that we needed to sort of scale up machine learning development was to move from this manual step-by-step experimentation to then build configurable and reusable end-to-end machine learning training pipelines. And we went from manually evaluating to creating more reproducible and logged experiments through our model management platform. And we went also from working more on local compute to leveraging scalable compute in the cloud through a container orchestration platform. So to describe this a bit more, so we had our notebooks, and we then converted these notebooks into an end-to-end automated training pipeline. So this is essentially a system that we built to enable us to configure the different pipelines. And we would then sort of version this in a versioning tool like Git, or we use GitLab. And we would then be able to build, test, and push Docker containers to encapsulate all the dependencies in our pipelines, and we would push that to a container registry and then do some basic configuration to ensure it was deployed to AWS Elastic Container Service. And there are multiple tools like this, but now the point of doing this is that once we have that pipeline ready in that way, we can then configure. So we could basically configure the specific parameters of the pipeline. We could configure how the data pipeline would execute, how the model pipeline would execute, and then we would be able to spin up this task in the cloud and run the complete pipeline through, and then log that as an experiment and log all the sort of model artifacts, etc., to our model management platform. And what is good with this is also that we can, as we have many different markets and sort of the experimentation here was quite extensive. So it made also sense to be able to run this in parallel to have us iterate a lot faster in terms of modeling. And this wouldn't be a problem when we set up it in this way. So then essentially all the experiments are then logged per model. So this is just how a specific tool look like. MLflow, it's commonly used, that is an open source tool. But I think most of these tools are quite similar. So we have the specific models that we're building to the left. So this is for instance, an LTV model for the Swedish market. And then each row in this that we have on the right corresponds to a specific experiment. And as you can see, there's a lot of different information on these experiments. So for instance, we are, if we click on one of these experiments, we can log all the different aspects that regarded or that were connected to the experiments, like the time frame for the data pipeline, which feature groups we used when building the model, what type of algorithms that were trained in this experiment, which build version was used when it came to the container orchestration, and how long it took to execute this pipeline. And you can imagine that more or less everything that you need to log, you can just log it as part of your experiment. And in addition to that, you can also, of course, log all your metrics that you need to use to evaluate the experiment. And then you can obviously log standard metrics like accuracy, precision, etc. for your train and validation and test data set. But you can also implement custom metrics, which might be more important for your business problem. But sort of all the different evaluation metrics you can implement, you can just track them here to facilitate then how you are comparing and benchmarking different experiments and models. And you can also track or store the model artifacts, like certain plots that you might need to analyze the model, and of course the model in itself. And you can also store like model explainability data and that type of stuff. And then we went into automating the model deployment to then start to work in the second loop and speed up model improvements. And the shifts that we needed to do this was to move from running inference manually, which was very time consuming, to then schedule end-to-end inference pipelines. And we went from versioning the code and the data to version also the models. And we went from manually releasing models to either do it automatically or as a one-click exercise in the MLflow user interface. And then we also went from doing sort of manual out-of-sample model evaluation to be able to run what we call configurable evaluation pipelines to sort of test the model in different timeframes, etc. And what I think is good with a model management platform is that it decouples the model producers, which are our training pipelines for our different use cases, which are pushing experiments and model artifacts to our experiment tracking part. And then we can select which models that we want to analyze further, and then manage the sort of model lifecycle in terms of that. So we can have it moved to staging, and then we can pick the best model and move that into production. And if the model then starts to decay in performance, we can then archive that model and deploy a new one. And then we can have our model consumers, which are the inference pipelines, evaluation pipelines, deployment pipelines, etc., just pull the model from the registry and execute these pipelines. So in the model registry, this is also MLflow and the second module of that solution. We have all of our different models presented here. So we see like the first row, there's like a German model. And we can then click on one of these models and see all the different versions that have been deployed for this model. And in case that we need to deploy a new model, we could just manually do it by changing the staging, as you see on the bottom right. And then if we set up our inference pipelines in this way, then we would just automatically fetch the model that is in production. So, and then we had when this was established, we then had to improve the monitoring and the lifecycle management. And what we did then was also to improve the decision dashboards, and then roll out the predictive return on investment or return on ad spend for all of the different marketing investments. And we could then also roll out based on certain prescriptive tools. Like we didn't only use machine learning, we also used a lot of simulation and optimization models. So we could also look into how we could optimize the investment portfolio in terms of how we are allocating our marketing budget. And we could also use that to create some insight that were also affecting the growth strategy of the company. And so moving into this last part, what we needed to do here was to move from manual monitoring to do semi-automatic monitoring, or I think it would make sense to do full automatic monitoring, but we were carefully following our business metrics here. And we went from having ad hoc roles to having a bit clearer roles and responsibilities. And we went from, as I mentioned, only using machine learning or predictive modeling tools to also use a lot of other techniques where the LTV model or prediction was an input for simulation and optimization purposes. And I think when it comes to how you establish these type of data-driven solutions, and when you think about MLOps, I think it's important that when you're building these type of solutions, machine learning is often one part, but you're often using a lot of other tools that you need to manage in your architecture. So in addition to machine learning, you might be needed to set up A/B testing, or you need to do simulation modeling or optimization modeling, as I mentioned, and you need to do certain statistical analysis, etc. So I think it's important to keep this in mind when you're building your machine learning platform, or you think about how you should scale these type of data-driven solutions. So MLOps is really needed to ensure reliable and valuable models over time through the model lifecycle management. So we were sort of, when we had these solutions in place, we were sort of continuously looking at the performance of the model, and we would refine the estimate if it was needed. And then I head over to you, Lena.
Yeah, thanks. No, but now, well, Niklas has told you everything about the MLOps, or at least everything that can fit into 40-45 minutes. And the question now is, if you're listening to this and you are not having MLOps in your organization, should you start doing it? How do you start doing it? What to do, what not to do? Or if you are already having some MLOps, do you need to change anything? Or do you get any good ideas what to change based on what you have heard from Niklas about just the general theory of MLOps and this example? And so the first question is, should you do it? Is MLOps right for your organization right now? And the first part of it is, are you ready for MLOps? So you have seen Niklas showing this seminal paper from Google about technical debt in machine learning systems. It's from 2015. So 2015 is when Google, like one of the biggest and most advanced companies, starting feeling the pain with their machine learning models. And of course they were a bit earlier than most of other companies. So to see this pain and the problems that require MLOps to solve, you probably need to have like more than one data scientist, several teams working in different technologies. That's when you have the issue with orchestrating it, with different teams consuming it. So before you feel the need, you probably need to have some size of your ML usage and growing of that size. And this is of course not to say that if you're a smaller company or if you're just starting with machine learning, that you shouldn't do MLOps. On the contrary, it's always better to start the right way. So I guess my point is that MLOps is for everyone. So you are probably ready to start implementing MLOps in a way in your organization if you're doing anything with data science, machine learning, AI, however you call it. The other side of the coin is MLOps ready for you? So are there tools or the best practices that you could use? And I think the answer is definitely yes. If we take a step back a little bit, I think that, at least in my experience, being a consultant in this data science area for a lot of companies in Denmark and Sweden, if you look at the last decade, it was mostly about just doing machine learning. So building proof of concepts, or even more just building proof of value. So you would create one data science algorithm, you would show some value. So I think this was most of what we were doing in 2015, 16, 17. It was mostly about data science algorithms and showing some potential of value. And then what everyone realized was that the missing part was data. So that this is bringing more data, having these data pipelines, that was a bottleneck for realizing any value. So everyone started talking about data engineering, hiring data engineers, and that was the talk and the main topic for everyone in, say 2018, 19, 20, maybe still now for some of the companies. And I think that now quite a few of the companies, or at least those that are more among the first movers, have solved that bottleneck at least. Maybe it's not perfect, but it's not preventing us from having value from machine learning systems. And then the attention shifts to productionizing, to putting machine learning models in a really industrial way, in a factory way, as Niklas mentioned, into production. And that's where the focus is on MLOps. And you have seen on one of the slides that Niklas presented, like a lot of MLOps tools and when they have been created or starting to get adopted. Myself, I had a MLOps startup in 2018. We haven't even called it MLOps. It wasn't really a widely accepted term at the moment. I have also seen, for example, Niklas mentioned Verta. I noticed it's a tool that I also used around 2018. It came out of a PhD project that year, so it was still stuff of academic research and PhD projects in 2018 or so. But now there are tools, especially with the big cloud vendors, creating more and more complete MLOps systems in past 2-3 years. So I think wherever you are and whatever framework or technology you use, be it that your data scientists are mostly using Python or some other and scikit-learn or some other framework, I think that MLOps are ready for you, and because the vendors have also noticed this focus on industrialization of data products. Like looking at some research, for example, IDC did a research where 75% of organizations said that their focus will be model productionizing in 2024 rather than building models or building proof of value. So again, in short, it's a yes for going into MLOps at your organization. And now that, okay, yes, we want to start with MLOps, how do you do it? Of course, you need a team, and you also need some technology, some platform, some tools. How should you approach that? And what we have seen are two typical ways. You could just buy and go full on some MLOps solution. So I have seen this recently, for example, at a large retailer in Sweden. They just went for one of the big cloud platforms for their MLOps tool, and it was, okay, this is what we use. We fit everything into this tool. And that can be quite effective if you, it's probably a good tool, and it's easy to buy, and you immediately have it. What they have noticed is that the tool was lacking some flexibility that they needed for some specific use cases, and lacking some feature that one of their teams really needed. And then it was really difficult to influence, and the feature was not coming, and they did not know when it would come. And this is all quite normal. What makes the problem bigger is that you are likely to notice these shortcomings only after you're already in, only after you bought. Because at the beginning, of course, you look, it has all these features, but once you start using it, once you start to implement something specific, you notice that something is missing. So that's the disadvantage of this approach. What I have also seen companies trying to do is just to try to use whatever they have, connect it, and make an MLOps platform from it. I have seen that in a large consultancy here in the Nordics, and it sort of makes sense because they were hoping then to use that MLOps platform at different clients. And I have also seen it recently in one organization that had a lot of software engineers and data engineers. So then their idea was, well, whatever system we have for our software engineering pipeline, so we use Airflow to coordinate stuff, fine, we can just build everything in the same way, use Airflow in the same way to coordinate MLOps orchestration, MLOps development. And this is, of course, again, not an ideal solution, as it's a lot of work. You have to build a platform with a lot of features. You start by thinking that you can make it more tailored to you, more flexible, better for you than just buying one of the big MLOps platforms. But it probably turns out that you don't actually have the resources to make it that feature-rich or that flexible. So you end up with something that might be a bit worse than one of the popular platforms, and not more flexible for you. So it may be worth considering if you already have good pieces to connect. But there is also a third way that I have recently seen in a large energy company in Denmark, where they sort of primarily used one of the big cloud platforms, but then built their own framework around it. So built like sort of a wrapper around one of these big platforms with still a possibility to fit other tools underneath or to customize it. So for a lot of APIs that typical MLOps tool would have, they would have their API like sort of one-on-one. but they were still able to have it a bit more customized. So it's probably a middle way worth considering. And if you're doing that, I think my only advice would be to try to use as much of all the existing tools and best practices as possible. Because when you look at it, machine learning is quite tough, and MLOps and productionizing it is also very difficult. Just all the reasons that Niklas has mentioned about lots of data, lots of difficulties in orchestrating. Scaling is always tough, so it's just better to get to take any help you can from existing tools so that you can focus on realizing value, so that you can focus on making your models and doing what's specific for your company. And provisioning containers in the cloud or somewhere is probably not specific and not what you should use most of your time on. So how to use what's existing? First thing would definitely be to just take a reference architecture, look how an architecture of an MLOps platform looks like, and use that. So what you can see here on the slide is an example on AWS, and this would work on any other cloud or with other tools. So the principles are the same, and I'm not going to go into details, but you can see here that there's a lot of boxes that you need to connect, a lot of boxes that you need to understand, and also here you can see that there are several different accounts and stages. So it can get quite complex. So better to start with a tested reference architecture such as this one than without it. And so the architecture, it's just the design of your system. But you can also get help to not only with the design, but with actual implemented pieces by starting from some infrastructure as a code template. So you can download infrastructure as a code templates, be it CloudFormation templates for AWS or maybe some Terraform templates for other systems, where you can just click and have something like what's shown on this reference architecture implemented in your cloud account or your systems. So it's again something that you can go and do. If nothing else, just then to try how it would look like, to quickly see how a set up MLOps systems look like. So yeah, take reference architecture, take infrastructure as a code template based on it. And then another thing that I would definitely recommend, and not only because I come from AWS, is to try to use the cloud to do the things that you don't want to focus on. So such as just ensuring that there are enough compute instances, or that you can easily deploy containers. So that's what we call undifferentiated heavy lifting, that it's better to leave to someone else to do. So I would definitely recommend to rely on the cloud. That doesn't actually mean that you have to do everything in the cloud, so that whenever you have a new version of your model, that you first have to deploy it in the cloud to see the results and to see whether to go that way. Most of these cloud platforms also have an SDK that enables you to work on your computer and just in an offline mode. So that can be a bit faster when you're experimenting, can be a bit cheaper also, while you still get all the benefits of having a model registry or having experiment tracking the same way that you would have in the cloud. So you can use those SDKs and those platforms while still working on your computer. And that's probably a good way to start and to experiment with developing. So if you have done this, so if you have taken a documented reference architecture, tested infrastructure as a code template, and you have a cloud to rely on, now you have probably good foundations to continue with your MLOps journey. And then you need to do all the steps that Niklas mentioned in the case example that he was saying. So essentially in this middle part, you have to ensure that your system produces machine learning models and pipelines that are repeatable, that are reliable. So whichever approach you take, whichever tool you take, you just need to check that it has this characteristic, that you can make everything automated and repeatable. That would mean that there is a version control system, that there is a deployment system that you can have continuous deployment in, that there is a way to store and monitor features, to store and monitor your experiments and models. So you have it repeatable. After that, you want to have it reliable. So to have all the monitoring, like for data drift, for model drift that you have seen in the previous example, to have the explanations, to have a bias monitoring, to have a feedback that you can use to share with your stakeholders or to have a retraining of your models. So then you have it reliable. And so this is something that you can actually find on the internet how to do. So a lot of what we have talked about, if you just spend a lot of time Googling, you would be able to find these examples and people talking about how to create a feature store or similar. So for this middle part, there are a lot of resources. It's of course easier when someone digests it for you, but it's possible to see how companies have done it. The last part, how you scale it. So once you have MLOps in one project or in one team, how do you scale it across your organization? How do you have more teams using it? How do you make it completely professional? It's a bit more difficult to find the information online, as not too many companies have done it. Being like the largest cloud vendor, we have seen quite a few customers doing it, so I can tell you a few key tips what they did right or wrong in this example. Again, if we just look a little bit like why is it actually sometimes difficult to scale? What do you need to balance? And there are some different needs that you need to balance. As a machine learning builder, as a data scientist, you want to be very agile. So you want to be able to just provision all the resources you need to get the notebooks, to get the compute machines yourself just with a click. You need to be fast in experimenting. You need to quickly respond to change if you have, for example, data changing because you had now different subscribers than before. So you need to be very agile to be able to do things by yourself, which sort of clashes with the need of central IT. If you're a big organization, your central IT probably wants to establish governance, to have security, to have all the compliance, to have the processes, to have the operations, to monitor the cost. So you have to balance the need of these two teams. And the other thing you need to balance is the need for results. So the need to quickly realize value from machine learning with the need to not to create too much technical debt, to do it in the right way. I think quite a few larger companies in the Nordics have now a problem to balance this. So typically, when you establish data science and machine learning teams, so you hire some data scientists, and there is this honeymoon period in the first year and a half, maybe 2 years, where everyone is quite happy. So it seems that you have some smart people creating models. They show that there is some value to be realized there, that they can create models that can bring value to your company. So it seems everything is good. But then after maybe a year and a half or so, you see that they are not actually bringing that value yet to your company. So that's the paradox of machine learning models that Niklas also mentioned. It's sort of deceptively easy to create proof of value compared to how difficult it is to scale it. So after that magical year and a half or two, you have very impatient business that still hasn't seen a return on investment, that really wants results. And you, in your data science machine learning team, you know that what you need is now MLOps, that's what's preventing you from realizing this value. But it's difficult to go in and say, okay, now give me half a year or a year to establish my MLOps platforms, and maybe then I'll start delivering some value to the company. So you have to balance that to be able to sort of in parallel still develop some value, give some value to the company, while not making things more difficult for yourself, and not just hack productionizing of these models at that point that you later, you or someone else has to go and clean up for a longer period. So yeah, you need to balance this, and the way to do this is to enable this governance with self-service. So you have both governance and self-service, which is essentially about creating templates for everything. What you would first do is to create these best practice templates, and what you can here do is to, if you're working in parallel, to have these projects that will deliver value soon, use them to create best practices. Use what you produce for those projects to become your templates for everything else. So start consciously with the idea that whatever you do in this project will become a best practice template for your whole organization. So maybe spend a little bit more time, but still work in parallel. So develop those first projects to buy yourself time to build an MLOps system. One thing that I should mention is that, and I was actually very happy to see some of AWS security services at Niklas's slides. A lot of people forget about security considerations and controls when developing machine learning. Because you just want things to work, you're a data scientist, you need access to a lot of data. Something is not working, you don't know why, so you just ask for full access to all data and all systems. So to data from different parts of the organization as you need it for your model. So it's easier just to ask for access to everything than to have to think what access and what level of access you actually need. So what I have seen is that then you have the data science account being like the most powerful account in the organization, having access to everything and the compute, and that's probably not what you want to do. So you need to think about what are the security considerations and controls you want to enforce. So you need to think, okay, if my model is exposed on an API, how is it being consumed? Is it only within our network? Can it be on a public network? So just a lot of things like that, but that's easily overlooked. So just think about what you want to enforce, make it into these best practice templates, and then once you have the templates, create these sort of catalog products out of them. So at AWS, it would be AWS Service Catalog, where you create catalog products out of your templates, but it would work similar in a lot of different systems. So you have to have some sort of catalog of these best templates for machine learning. And then to enable that people use that catalog, that they can go into the catalog, find the template, find what they need, click and get it immediately deployed in their accounts, in an environment that they have access to. So that's what you can see here on this slide. It's just an example how to launch a notebook in Amazon SageMaker in this sort of controlled way, where you have a service catalog, you have created your template, put it into storage, connected it with the service catalog, and then a user would go into the service catalog, choose this template, then use this infrastructure as a service such as AWS CloudFormation to get it deployed into their accounts. And this way you have both. You have someone who can click and get the resources that they want, and those resources are from your best practice template, so with the security and everything else built in already, but it was still, like they didn't have to submit a ticket and wait for several days for IT to give them this notebook. So this is how you can enable this provisioning of ML environments, how you go from having one good project to everyone in your organization being able to use the same process and the same good templates in an easy way. So to have this full scaled MLOps. And the other link here is also how to promote reusability between projects. So service catalog is one thing. You have your templates there. You have your template for a notebook. You have your template for a machine learning pipeline. But it's more than that what you can reuse. So it's not only the data that you can reuse in the machine learning platform. There is probably a lot of code or a lot of products that you created in one project, your orchestration code, some of the training code that doesn't depend on the shape of the data, some of the deployment code that can be reused across projects. So in addition to the service catalog, it would be good to have some sort of store, some sort of searchable enterprise store where you would publish and then later consume these other kinds of artifacts, other kinds of reusable products that you create as part of MLOps platforms. Yeah, so these were just some tips from seeing how other companies in the Nordics have done it, how to start with MLOps. How to choose the tools, how to scale it. And of course the part that you have heard from Niklas, which was about that you need a team and you need an organization behind this working in the right way for MLOps. Yeah, so I think it's time to summarize what we have been talking about. Yeah.
All right, so thanks for listening in to this crash course. I hope you have got some information that are a bit on the high level, a bit on the low level, but what we have essentially walked you through is why MLOps is crucial for companies that want to scale machine learning across the organizations, and why it's important. It is needed to free up time, speed up the time to value, and to ensure that models remain valuable and reliable over time. And MLOps is a set of practices that aims to deploy and maintain machine learning models in production. And we have also talked a bit about how we can introduce MLOps in the organization. And we have stressed that it is important to do this gradually and also based on business needs.
Yeah, so I think that's a good way to end this crash course by just again reminding people to come and join the next ones on API security and, as I said, data ops on 1st of December and business-driven cloud adoption next year.
Yeah, so looking forward to maybe see you then. And thank you very much for listening in to this webinar. And as I mentioned, please reach out if you have additional questions.
Yeah, thank you, and do get in touch.